Alrighty. So I guess we're live. So we have Victor. Hello, Victor. So I'm live from California in the US. Let me know in the chat, where are you guys coming from? As we wait for others to arrive in a few moments, we're going to begin. Hey, Jess. Hey, Dan. Yeah, so this is the Streamlit quarterly showcase for Q3. And we're getting started soon. As you can see here, we have a packed agenda today. So lots of good updates from our product and engineering team. Hello, Adnan, Carlos from Brazil, Victor, Chile, Dan, Connecticut. Hello, Sarab from India. Hey to Heroes Tech from Ghana. And we have Francisco from Chile. Cool. Shayon from New York. Onido from Berlin. Hey, Sebastian, how are you? Also from Chile. We have Ian J from Seattle. All right, Bart from Holland. Rui from Portugal. Peter, Germany. Hello, Awit. Okay, cool. Alrighty, let's start with the second slide. Alrighty, yeah. So I guess we've already covered the first agenda, is where are all of you streaming from? So essentially we're having from all over the world. That's pretty cool. Okay, so Jess is tuning in from Boston. Arnaud, our Streamlit member from France. Hey, Fanillo, welcome. Glad to have you. So Fanillo is coming from France today. Yeah, love that. That is Fanillo yesterday. Pretty cool. Hey, Kamel. Hey, Siddhant. Okay, cool. Siddhant all coming from France today as well. Jacob from Poland. Awesome. Alrighty, so what are some of your favorite Python libraries that you like to use alongside Streamlit? I mean, like for me, like the typical data stack works for me. Like, you know, obviously NumPy, Pandas, Altair is also my go-to for like data visualization. And as for like LLMs, I'm using OpenAI and also Anthropic. And yeah, there's so many exciting tools out there nowadays. Let me know in the chat. What are you guys using? Streamlit nightly? Cool. We got Langchain from Sarab. Arnaud with Pandas. Awesome. Snowpark. All right, Snowpark. Yeah, that too. I'm also using that as well. Cool. Pandas, NumPy, Streamlit. 80% of all my apps. Awesome, Sebastian. Awesome. Alrighty. So we're gonna get started in a few more seconds. Hello to Christian from New York. So he's using Tableau server client. Okay, awesome. Tableau admins. Okay. On Udo, Pandas and Altair. Yes. Audio stuff. Dan. Awesome. Yeah, I'm also like exploring content creation using Python, like to use it to automate some tasks, like doing jump cuts and all of that processing. Alrighty, so I guess we're all warmed up and ready to begin. So let's enjoy the show. Hello world, I'm Chenin, Senior Developer Advocate for Streamlit at Snowflake. Some of you might know me as the Data Professor from a YouTube channel. I'm super excited to be your MC today. We do these events every quarter, so you'll have a chance to hang out with the product and engineering teams to learn about some of the latest features from Streamlit, and also see some pretty cool apps from the community that extends what's possible with AI. So before we get started, our legal team asked us to put the disclaimer here since we're talking about product roadmaps. Let's take care of some quick housekeeping. We'll have swag drops at the end of the showcase, so stick around to find out how to join. Eligibility rules will be shared with the winners. This is your chance to talk to the product and engineering team, so please ask your questions in the chat. Although we won't have time for a live Q&A, we're ready to answer your questions live as they come in. So do note that this live stream is being recorded to watch on YouTube. We've got a pretty super packed agenda today, and so we'll start off with our co-founder, Tiago, who will kick things off with an opening talk on Streamlit 2025. Then we'll have Johannes, Streamlit Open Source Product Manager, Nico, Bob, and Eric, our engineers, to talk about some of the latest features that we have from Streamlit. Diana, Senior Product Manager, will talk about what we have in store for Streamlit Community Cloud. Then we're going to dive into 4 different ways on how to extend the possibilities of using AI and Streamlit. So Arno will talk about some of his experiences in building out the streamlit-extras component on how innovation to become obsolete and still loving it. Carlos will talk about Cortex toolbox and everyday toolbox using Cortex and Streamlit and Snowflake. Sebastian will share his most explosive app on Streamlit. Sumant from Clarify will talk about data labeling using GPT-4 Vision. So without further ado, please welcome Tiago, co-founder of Streamlit.
Hey, my name is Tiago. I'm a co-founder of Streamlit and a director of product here at Snowflake. And today I wanted to talk about Streamlit 2025. If you teleported here somehow with no context, which I'm not sure how you found this presentation, but here we go. Then let me just first backtrack and tell you what Streamlit is and talk about some of the things I talked about last time around. So Streamlit is a Python library for building data apps, blazing fast. We want to let you build apps as fast as possible. And we do this in 3 main ways. We try to make interactivity trivial. So we make it 1 line of code. You just type st.slider and assign it to a number, and you get a slider on your app. It's that easy with basically all the widgets we have and charts and all of that. And the second way that we make development fast is by letting you bypass having to think about the tech stack and focus on your analysis. So you can forget about all of this junk and all the decisions that you usually need to make about them. Do you pick, Redux? Do you pick Webpack? There's all these different things to think about. With Streamlit, don't think about any of it. Instead, just sit down, tell Streamlit what you want, and Streamlit does it. So, you type st.write, and Streamlit writes that thing to the app. You type st.line chart, Streamlit builds a line chart and shows it on the screen. Again, that easy. And the third way we make development fast is we foster a tight iteration loop. We do everything to keep you in a super tight loop. And what does that mean? Well, you open your editor and you type, and save. Now you have an app, and you show this app to a colleague, to stakeholders. You get feedback, and then you add. Somebody will ask, "Can you add control widgets to this to modify some parameters?" And then you type, save. Now you have those widgets. Really tight loop. So you share with people again, get feedback, rinse, repeat, rinse, repeat, rinse, repeat. And that's the magic. Like, you don't have to plan the whole app ahead of time. Instead, you just build it. This lets you just get started with zero friction, very low barrier of entry, and then keep iterating, keep building, keep improving. And every year we want to make this more powerful. And how do we do that? Well, let's look at what we did in 2024. In 2024, we gave you selections on data frames and on charts. So now you can click on a chart and get the result back on Python, the thing you clicked, and then do something with it. We gave you multi-page apps of V2. This is a new st.navigation command that lets you set up your navigation in a much more intricate way. Give you the ability to rerun only a subpart of your app with st.fragment. Super cool. So you don't have to have a slow computation somewhere in your app. Only a small part can rerun if you click a button. Things around that button will be the things that update. st.dialog for dialogues, huge request from the community. st.popovers as well. HTTP headers and cookies with st.context. Great for enterprise. Query parameters also used a ton on enterprise. HTML support, audio input, feedback widget, and a ton of customization improvements. And there's a lot more. And by the way, the year's not even done yet. So there's a lot more to come. But let's see what the result is of all this. And basically, the result is that all our metrics are looking like that. It's a big hockey stick pointing up and to the right. And it's been really exciting. So, but we're all numbers people. So let's look at some numbers. Our monthly active developers grew from a year ago, 170,000 more or less, to 360,000. And that's 2.1 times year over year. It's insane. Monthly active views grew from 5 million more or less a year ago to 10 million. That's again 2x year over year. Number of cloud apps on Streamlit Cloud from 250,000 to 570,000. So many year over year, 2.3x. Like, it's really 2x every year since inception, and it just keeps going. It's incredible. And so I want to show you how we're going to maintain this. This is where we are today, and how we got here. Let me talk about what's coming next. Maybe, because our lawyers tell us we can't promise anything, and it makes sense. So we're not promising, we're just showing what we got planned. And besides, there's that famous aphorism, all plans are flawed, but planning is essential. So having these plans is great for us. We're going to try to be within these boundaries. And you'll see if we change our minds, will be because there's something more interesting coming up anyways. So with that, here are 3 objectives for 2025. The first one is to ruthlessly prioritize enterprise blockers. The second one is to become the best interface for LLM apps. The third one, accelerate investment in our foundations. Let's talk about the first one. So we hear you. The big ask here is more customization. And boy, do we have news for you. We have a lot of things coming up. So theming V2, layouts V2, components V2, localization, a lot more. And just from this list, I'm already excited for 2025. Seems like it'll be a very exciting year. So let's move on to next, LLM support. So our pie in the sky goal here, very pie in the sky, but maybe achievable, let's see, is to make Streamlit apps, chat apps, competitive with what big AI companies launch when they have a whole dedicated team to do it. And this means audio and video support for chat apps, attachments for context in the apps, editing, feedback directly in messages, action buttons, example buttons, safe code execution, and a lot more. And following up, the third objective that we have is to accelerate investment in foundations. And this is growing the things you know and love about Streamlit. Basically, like adding more tools to our tool belt. So more widgets, more options, but also a better coding substrate for us to develop faster Streamlit itself. And we also want to improve performance. There's a lot of low-hanging fruit here. All right, if this presentation is missing some hot demos, then good, because next up, you're going to see a preview of the things that are to come. And with that, I'm going to pass it on to Johannes. Onward to another 2x growth. Thanks.
Hey everyone, I'm Johannes. I'm a product manager on the Streamlit open source team, which makes the Streamlit library and all the cool features in there. So I'll just show a quick demo of a new feature that we built, the Streamlit Playground, and then I'll pass it off to our engineers who will show you some of the features they built in the past few months. So Streamlit Playground, this is a new thing we're currently testing on our website. If you go to streamlit.io/playground, then you will land on here, and you can see that this has a little editor on the left side and a Streamlit app, a frame on the right side. And so this is really thought for if you want to quickly try out Streamlit, if you just discovered it and never tried it out, or if you have something where you just want to try out something really quick without installing anything or signing up. You can just go to this page and you can enter some code here on the left. So I can, for example, write st title, hello showcase, and you can see that this should rerun, and it shows it in a Streamlit app embedded right in my browser here on the right side. And I can also display, for example, a slider or all kinds of other interactive elements, and this will also show up here. This is all running in the browser, so it's not using a server or anything like that. It's using the ST-Lite package, which I'm sure some of you have seen that Yujiro from our community built. So this is running Streamlit and Python completely in the browser. Yeah, and it's just a very cool thing to try something out in Streamlit. It's obviously not the real library, so there are a few small restrictions, but you can try out pretty much anything in here and then copy it to an actual app. And we also added some examples here. So there's a little hello examples with a button and balloons. There's some examples of charts in here. Yeah, some examples of data frames, also LLM chat, computer vision examples, geospatial. Just a few things for you to briefly see what Streamlit can do and try it out. Yeah, that's already everything from my side. And then I'll pass it off to Nico, who will show you some stuff about audio input. And then Bob and Eric will also show you some other features that we developed or that we're currently working on.
Hi, everybody. My name's Nico, and I'm an engineer on the Streamlit open source team. Today, I'm going to show you a new widget that we've added to the Streamlit open source library called the ST Audio Input. ST Audio Input allows the user to record their microphone from their browser and interact with the WAV file of the recording on the Python side of things. Users can record in the browser, seek and play back, and once it's in the Python side of things, it's present as a WAV file so that you can use any of the tooling in the Python ecosystem to interact with the file. So let's jump into a demo. So above here, you can see how the widget is instantiated. You call ST audio input. Right now, it's still as experimental, but in the next release, it'll be ST audio input. And on the left here, you get a variable that will include the WAV file's contents in memory. Below here is the widget as it's rendered. Clicking this button will allow you to record, and you can see that it's recording with the waveform indicator here. Once you click the button again, it will stop recording, transcode it to WAV, and upload it to the server. So within this component here, you can play back and hear the audio. You can seek throughout it. And here's what I did with the WAV file on the Python side of things. We did a little bit of peak detection and plotting the amplitude of the WAV file over time. A fast Fourier transform to do frequency spectrum analysis, as well as a spectrogram. The possibilities are endless. So yeah, that's the ST audio input. And next we have Bob showing an update on selections on maps.
Hi, everyone. My name is Bob Nisko, and I'm an engineer on Streamlit. I'm here today to talk about selection on maps, a new feature that was launched in Streamlit 1.39, and it brings interactive GeoViz to Streamlit. Let's dive in. What's new today is that st.pydec chart can now return selection state. So if you have layers on a map, a user can now interact with specific objects on the layers. We support two different selection modes, single object and multi-object, which gives you as a Streamlit application developer a control to say how users should be able to interact with the objects on the layers. What I like so much about this feature is that it's really fantastic out of the box. So it does things like automatically handling color differentiation between things that are selected and non-selected. It will also handle things like deselection. So if you want to clear your selection, you can click on something outside of any layer and all the selection state will be removed. Or if you have a bunch of things selected and you just want to deselect one of them, clicking on it a second time will deselect for you. Selection works across multiple layers. So it doesn't matter if you have 1 layer or 10 layers, all the feature sets here will work across all of your different layers. I want to show this in action. So to do so, I'm going to jump over into a different browser tab. Here we have a Streamlit application, and I'll walk through a little bit of the API. st.pydec chart now takes an onSelect parameter. This looks a lot like a lot of our other interactive components in Streamlit. In this case, we give it the keyword rerun, but this could also be a callback. It returns some data, which we're putting in a variable called event data. The structure of event data is as follows. It's a dictionary with a top-level key called selection. Underneath selection, there are 2 other objects called indices and objects. And in each of those, there's a dictionary on a per layer basis that has an array of all the selected object data. I'll show you what this looks like a little bit. Scrolling down here, we are printing out the event data. And right now, since nothing is selected on this map, all the objects are empty today. But note that this is also automatically stored for you in session state, and it's the same data. So if I take a look at this map and I click on a specific object, we'll get back a new key inside of the indices and objects dictionaries. It's called myHexLayer. That's the name of the layer of the object that we selected. And it gives us both the index and the actual underlying object. If I click around and select different ones, we'll see this updates for us. And if we go to a different layer, note that what used to say myHexLayer is now a different line layer called bartlines layer. And all the object data is also here for us. So that's single object mode. Let's take a look at multi-object mode. I'm going to do essentially what I just did last time, and we'll see how this actually appends data to it rather than replaces it. So I'll select that hex object, and then I'll select a second hex object. We now get both of the things that we've selected on both indices and objects. And again, since this works across layers, we can select things on a different layer and now see that we have all the hex layer stuff, all the lines layer stuff in both indices and objects. This works across all the different layer types in PyDec. So things like H3 clusters, GeoJSON. I won't go through all of them, but it works across all of them. For this demo, I wanted to show off a really fun app that I built that shows the power of selection on maps, as well as existing Streamlit things like forms. So I built a little application called Find the City, where you have a PyDec chart with a single scatter plot layer. It's got about 30 cities all across the world. Below, we have a street view where we have to try to figure out, based off of the street view, where in the world we might be. Taking a look at this, to me, this looks like somewhere in Brazil. So I'm pretty sure this is Rio. So I'm going to go ahead and select Rio, and I'll submit my guess. I get st.balloons, which indicates that I got that one correct. I won't go through all of the 30 cities in this game, but I hope this gives you a really great inspiration for things that you could build with selection on maps in Streamlit. That's all I have for today. Up next, we'll hear from Eric, who will share insights on file upload for chat in button groups, pills, and segments. Thank you.
Hi, I'm Eric Chu. I'm a senior software engineer on the Streamlit open source team. Today, I'm going to share 2 new exciting updates. One, file upload for chat, and button groups with all of you. So first off, we have the file upload for chat. We're looking forward to roll out a preview of this component alongside for the st.chat_input. This is one of the top requested feature by all of you. So hopefully you will be able to help us test this in the preview. So I'm gonna head over to our site to show you quickly how it works. So with our standard st.chat_input component here, you now have this new UI component that allows you to update one or multiple files. Cool. So there you go. You will be able to upload files as long as with your chat message. And the usage is pretty simple. Here you can see that in our current chat input command, now you'll be able to specify that you want to accept multiple files and specify the file types that you allow. Cool. Next up, let's talk about button groups. In this update, we introduced 2 new commands, st.pills and st.segmentedControl. These are 2 commands that helps you create collections of similar type action buttons, or in some scenario, you will be able to use it to switch between different options. So let's look at st.pills first. So here you can see each options, we're able to show the label for the button, or it also supports different icons. You also have the options to show icon-only buttons as well. And the usage also, it's pretty simple. You'll be able to provide a label for this component and a list of all the options in your button groups. And we have 2 selection mode. One is multiple, one is single. And also some other features that we have alongside with other Streamlit components here. Cool. And let's look at the segmented control a little bit here. So here also we have support for multi-select for segmented control button groups. We also have single select available for you. Usage is very similar to st.pills. You have support labels, and you can provide all the options for this button group component. Cool. So that's it for the 2 features I would like to cover. Up next, Diana will enlighten us with the recent advancement in Streamlit Community Cloud.
Thank you to the open source team, and we are transitioning now to the cloud updates. I'm Diana. I am the product manager for cloud and fairly new to the team. Today, I wanted to share a few updates, starting with a recent launch of Streamlit profiles, and then 2 quick updates about the forum and some recent performance gains for app loading times. So starting out with Streamlit profiles, this is a new feature that we quietly rolled out incrementally starting in the summer, and it's actually been a feature request from many of you, particularly Streamlit super users. And so we're super excited to share a little bit more about Streamlit profiles, which is now in GA on Cloud. So if you're not familiar with Cloud, here's the link. Just sign in, particularly through GitHub Auth, and profiles are also on mobile. So the purpose of Streamlit profiles is really the same purpose as a LinkedIn profile or a GitHub profile. It's really to showcase your work and also let your personality shine a little while we're at it. And so with Streamlit profiles, your public profile page has your own URL, and it has a central place for apps, and it also has a section for you to add your bio. I'll actually just share a prototype right now, which looks very representative to what you'll see in Cloud logged in today. So looking at Arnaud's pretend profile, we'll see that he can edit his socials, his bio, and his featured app. Right now, his featured app by default is his most viewed app, but you can change your featured app and what shows up in this flagship area in the app settings here. And we'll also see that Arnaud has 132,000 total app views across all of his apps, which is very impressive. And this featured app area, as well as the total number of app views and just more social proof for Streamlit super users, were highly requested features in particular. And we do plan to build out more badge integration, including from Forum, and more customization features. So drop in the chat any feedback or questions that you have. Also, we wanted to share this sharing feature, which looks how it sounds. So you can copy the direct link, and you can also share on socials of your choice, including GitHub and Forum. And this preview feature right here is coming soon. It's not in GA yet, but the idea here is anytime you share your profile, the viewers on the other end can see this preview of your profile, and they're more likely to click into it. Now, let's transition into viewing profiles from other community members. So let's pretend that you see this viral Hello World app on X. And so you want to click on the URL. And what has changed here is now you can see who is the human behind this app directly from here. And you can do that by clicking on this avatar. And you'll see that Tiago's the owner, and these are his 3 most viewed apps that you can preview. You can click onto any of these apps, or you can view his profile where you can see all of his apps and what his flagship app is, and learn a little more about him. You can also even reshare Tiago's profile if you want to. All right, so that's the main updates for what Streamlit profiles are. Give them a try, give us feedback, and let's move on to 2 other quick updates on Cloud. So for the Streamlit forum, we recently did redesign the UI so that it looks and feels more Streamlit-y. And so you can think of this UI redesign as just one milestone of many more to come in order to make a more cohesive experience across Forum and Cloud. And just to emphasize, for the forum, we preserved all of the same functionality, and so no functionality has changed. You should find Forum much easier to navigate because of the design changes, though. All right, and our last update is also very exciting. There are now faster app loading times across really common interaction patterns that you have with Streamlit apps, including viewing apps on Cloud and deploying apps and installing dependencies, thanks to the engineering team implementing UV for the local development experience. So the takeaway for you is to try UV pip install instead of pip install. And the engineering team, particularly George and Alex, wrote a Streamlit blog to share more about how they cut down the loading times by half. And so if you want to read this blog, here's the URL. And that wraps up our product updates. And I will pass things off to Shannon.
Thanks, Diana. Super excited about these recent updates to the Streamlit Community Cloud. Speaking of which, we'll now proceed to some cool apps that our community has built and also from our very own engineers. As AI evolves at lightning speed, it's reassuring to know that you could try out any AI-powered Python libraries and practically any of the thousands of libraries that you can install via pip as you build out your web app with Streamlit. And you can do that using pure Python with no knowledge of front end required. So in this segment of the show, we'll hear from 4 Streamlit builders. So there's a lot to unpack here. Do feel free to ask questions for our speakers in the chat. First up, we have Arnold, Streamlit Senior Product Data Scientist at Snowflake, to talk about his experiences building streamlit-extras, innovating to become obsolete, and loving it.
Thanks, Shannon, for the intro. I'm very happy to speak today about streamlit-extras, which is a project that we started a few years ago. And it's a funny project because we both wanted to live long but also die fast. And so I wanted to talk about that today. It's kind of a special project. So what is it? It's a Python library. It's really just a side project that we started within the data science team at Streamlit. And we wanted to share our tips to the community very easily because our daily jobs are really like just about building Streamlit apps that look at the metrics and how Streamlit is being used in the world. So we're using Streamlit a lot, and we wanted to share those tips and those kind of tiny, simple Streamlit components. Most of them are static ones that either just use Streamlit itself and like at most we'll use like some static HTML or CSS, but nothing crazy like bi-directional JS stuff. So we just wanted to have like a placeholder, like an aggregator of all of those very simple functions and make those things accessible to the community. And the community kind of likes it. It's going great. Thousands of apps use the library, and we have over 50 extras within the library, which is great. And some examples of that are, for example, the image selector, which I'm gonna like show you in a demo right after, that allows the viewers of your app to select an area on an image. So maybe using a lasso or a bounding box. And another one is the data frame explorer. So it's a way for your viewers to filter a data frame themselves, so they can self-serve some filterings, looking at specific parts of your data frame. And for example, there's a new one that was merged last week from an external contributor, and it's a funny one because I think earlier today we've had this presentation about upcoming multi-button coming to Streamlit, and so this one is like a community proposal that does exactly that, using built-in Streamlit, helping you to do this multi-button UI. So it should be available now. And I wanted to show you one or two of them using our documentation, which happens to list all of the extras that you have here. And when you visit, like most of them are have what I call like an ST-Lite playground. So again, shout out to Yuichiro, Streamlit creator that built ST-Lite. It's a way for you to run Streamlit in the browser. So I'm using that to make the examples a bit more concrete in the documentation. So for example, here, I'm looking at this image selector. There's a single function. The way you're going to use it is this thing here. You just import it from Streamlit Extras image selector. import image selector, right? And then if you look at the code, what you would typically do is get an image, put it into whatever Pillow or NumPy array, whatever format is supported, and then create your Streamlit radio button just to have people choose between a lasso or a box. You can also hard code it, right? But here I'm making the example more intuitive. And then you pass the selection type to the image selector, you pass the image, and the output is going to be a selection, and it's going to be a JSON, kind of consistent with how selections on like data frames or charts or now maps happen in Streamlit. And so here you see that I can select the beautiful eye of that cat, and I get it as a JSON, as I was saying, like a dictionary. You get all of the output here if you wanted to reuse them somewhere for like some data annotation task. And I also built this a useful show selection if you wanted to see what you selected. So that's just an additional util that's within the extra. There's a lot of them that you can look up here, and yeah, as I was saying, most of them have an ST-Lite playground, so you can really play with the actual extra. So yeah, and I'll go back to the deck to tell you more about what's funny about our project. So yeah, there's something quite special with streamlit-extras. Is like we're on a funny mission. We want to live long, and we also want to die fast. Like both are reasonable forms of success for us. And I'm gonna expand a little bit on that. So there are two successful paths for any extra that exists. On the left side, you can see there's the live long and be a useful extra path, which is great. There's this chart in the bottom saying like through time, the extra will get incremental usage and convert at some point, which is totally fair. It kind of reached the target in the community that wanted to use this thing, so that's great. And it's just not as special as some others that are in the like second path, which is the shooting star path. Those ones are the like die fast and be a shooting star extras. That they're so brilliant in a way that they kind of disappear to become like a proper Streamlit native offering. And for them, the adoption curve is pretty different. You can see like the blue curve is gonna grow, but at some point Streamlit is gonna decide that they should build a more solid and bulletproof and native offering that kind of resembles to that extra. I mean, they have a lot of signals, right? Not just streamlit-extras, but like GitHub issues and everything are probably contributing a lot to the roadmap and more than streamlit-extras. But still, you'll see that it's happened more than once than that some extras actually get into the library. And so whenever the Streamlit release happens, the extra goes down in usage, which is great because there's a native alternative that grows and will grow even more than the extra, right? I didn't emphasize that enough in the chart. I realize now, but like the red curve is actually going to go way higher than whatever the blue maximum was, which is great. Like the solution is bulletproof, and the massive outreach that Streamlit can have as a great open source project is going to be even wider, and so this thing is going to be like better and more popular. So yeah, we're happy if the extra dies. It's actually a good thing for the community. So I wanted to call out this memorial wall, which is really just shout out to all of those extras that are now obsolete, and it's a one of its kind form of success to me. And so there's a bunch of them. Maybe you've used them. Annotated text is one that is now just fully replaced by colored text in Markdown. We've had an app logo was really hard coding some ugly CSS to add the logo on the top left part of the app. Yeah, now Streamlit has it natively. That's ST logo here. The switch page function that Zachary built is also just purely now inside of the API. So that's great. There's a lot of them that are honestly now pretty useless. They have some subtleties, but you should honestly just use the native offering. And what I like about them is about this whole life cycle is it's really like the full cycle of a community idea that's being prototyped in a side library, and it evolves from those prototypes to solid Streamlit solutions. And so I think it's an interesting path for new features actually. And with that, I wanted to thank you and invite you to ship more useful extras and shooting stars. It's really easy. Just visit our repo. We have instructions to contribute. And yeah, thank you for having me.
Thanks, Arnold. It's amazing to see how these cool widgets from streamlit-extras goes from an extra widget to being reborn as a native feature in Streamlit in order to help extend the functionality. Next up, we have Carlos, who will be sharing with us about the Cortex toolbox and everyday toolbox using Cortex and Streamlit in Snowflake.
Hey everybody, my name is Carlos Serrano. I'm a Senior Solution Innovation Architect here at Snowflake. Today I'll be demoing for you my Cortex toolboxes, an everyday toolbox using Cortex and Sys that I created to just simplify my life on my day-to-day work. One of the key features of it is it has a chatbot for simple tasks. Sometimes you need to generate data or simply ask a question. It is a really handy tool for that. It has some code explanation interface and code formatter interfaces using LLMs, but it also allows you to do multi-model prompts and just be able to compare how different models interpret your prompt. So let's dive into the code. Here's the basic interface. Once you get to the Cortex driven toolbox, you're going to see 3 buttons on your top right hand. One is for chat, explain, and format. They all allow for multi-model execution. Multi-model is done by leveraging Snowpark async job definitions. The way that I designed is contains a system messages class that contains 3 different enums for each workflow. This provide different set of instructions for each workflow as system messages for the LLM call. We have some callback functions just to do some session state management and eliminate prompt history or just rearrange prompt history. And then we have our class for prompts. In our prompts class, we have a compose prompt. Basically, it creates the final prompt to be sent to Cortex. And this is where I attach the system message and sanitize how it's going to be executed to Snowpark using the complete function. And once I execute to the complete function in the submit prompt, I am actually logging into session state before executing everything. So I'm creating a session state key using the LLM model selected or model selected, and the prompt and an async job definition. I'm using the 2pandas block equals false attribute, and this actually returns an async job for Snowpark. This allows me to dispatch multiple model calls and check their status later and not have to wait for each model to resolve sequentially. Once these has been set to session state, I can then continue with the rendering portion of it. It is going to create columns dynamically depending on how many models you have selected. In this case, I have limited to 2, but you could use infinite number of models of columns depending on your screen size. For rendering the prompt, I'm using experimental fragment, and I'm checking for the completion every 3 seconds. What this does is that it goes and verifies if the session state key corresponding to the response is an instance of an async job. If it is an async job, it will go and check if it is done. And if it is done, it's going to replace that key with the actual values from the response. That way, I don't have to go to Snowflake again and query the result sets again every 3 seconds. If it is not done, it will log it as pending, and it will go through it again and check if it's been done on the next iteration. And that is done on this render prompt frag method. The async job definition has a method called isDone, and that is a method that allows us to know whether the query in the background has completed, and we can return and retrieve the result sets using the .result functionality. Once the results are retrieved, then I can render them using that experimental fragment and keep refreshing them in case that more changes are needed. From a workflow perspective, there's 3 workflows. There's a chat interface, there's the explain, and there's a format. Chat is very simple. I can come here and ask my chatbot for something. Generate a sample set of 100 records of demographic data in CSV, for example. And I'm going to execute this against these 2 models, Mistral Large and Llama 2 70 billion. Because it's an async calls, it's actually going to log each on session state and know that it has to go and check again because it's an async job. Using experimental fragment, as the jobs are completed, it can replace the async job with the actual result set, and I can get my result sets back in different timings. And this was the main purpose of doing it this way, was be able to start reading without having to wait for each of the calls to complete. In this case, it looks like Llama 2 couldn't completely fulfill everything, but it generated a random set of what I wanted. Just didn't generate the whole 100. But if you see here, I got another sample set. So you can see how different each response have. And I can use this to evaluate different responses from different LLM models and see them side to side. If I move to the explain side of the application, I can actually click explain, and I can paste a piece of code that I want to get explained. In this case, I'm going to change, I'm just going to use Mistral Large, for example. I'm going to click explain, and this is going to execute the same workflow, just with a different set of instructions because I changed my system messages behind scenes. And this will execute against the model selected. It will await for the response to be completed and then return my result sets with the explanation of the code. This all happens by leveraging the callback functions to change the system messages and the workflow type on each of these buttons. That loads those messages into the submit prompt function and changes how the LLM behaves with each interaction. And then I get a code explanation. I can use this if I want to compare the code explanation of 2 different models. And last but not least, I can use the format function. And with the format function, I can grab a piece of SQL. For example, I'm going to grab this piece of SQL here, or Python, or whatever language you want to format. If you see here, my unions are next to each other. I want to format this code. And I'm going to select Snowflake SQL and execute format. And this will run it against the LLM selected and retrieve the formatted code. And I can then copy it and continue using it. So these 3 tools simplify my life on a daily basis, and I just wrote a Streamlit app to get access to these. It's all using very simple tooling in Streamlit and Snowpark, and definitely leveraging the async calls makes my life a little easier. I don't have to wait for each response. Hope you enjoyed, and if you have any questions.
Thanks, Carlos, for sharing how you're leveraging Cortex for your day-to-day coding. Let's now hear from Sebastian.
Hi, everyone. My name is Sebastian Flores. I'm a part of Streamlit creators, and today I will be showing you one of my latest app, which I developed for a company that provides services of analysis to mining companies in Chile, and it has been quite fun to develop this app. So what was really interesting to me is that when they contacted me, they had a very innovative and complex piece of code, which was on a Jupyter notebook with lots of raw code, where they had lots of computer science and computer vision analysis to help analyze the recordings of explosions on the mines. And the first step was to take this and to pass from the experimentation, from the development of the code, to a small code library where everything was packed in a better version, in a better way, and where the Jupyter notebook now had a more clean interface where no imports and hard to read code was presented to the user. And that was right away very good, because the final users don't have installed 500 libraries on their computers, and not everyone knows how to use Jupyter Notebook. So this, while it was better, it's still a step behind what an actual final user would love to use. So that's where I stepped in, and I developed an interface using Streamlit, where I use the same backend code as the Jupyter notebook, but we're just presenting things to users in a different way. And this has the nice side effect that you can deploy to the web very easily. People can focus on their strengths. So we get the interface very easily with Streamlit, and the science team can keep upgrading all the algorithms and functions on the backend code. Some of the key features of this app is that Streamlit is just the interface. You can keep doing science as usual, and if you improve the code on the backend, you receive that on the front end right away. There are some the flow for the user. I try to provide a very step-by-step, very friendly functionalities to the user, and they are unlocked as the user provides inputs and does the required steps. The Jupyter Notebook had a part where users had to select points using OpenCV, and I replaced this with Streamlit image coordinates. So thanks for the community and all the people that participated in creating this component, which was very easy to use and to integrate, and as I'll show you, work very, very good. And I have been developing a set of helper functions that make developing and performing some admin task on the Streamlit app very easy. So one other thing that I would like to highlight is that the new navigation menu is very, very good. It looks very clean and professional. It's very Pythonistic. I use it to set up admin roles. So the regular user just get some pages, and then as an admin you can do more stuff. And I can even add the authentication with a simple decorator I provide for within the helpers. So let's jump into the demo. So as I mentioned, if you're just one regular user, when you log in, you just have a couple of functions. And as you can see, things are disabled by default. If you log in as an admin, you have more pages, and these pages allows you to navigate, for instance, within the folders that you have on the app, and this is very useful when you have deployed your app to the web. You can see the different libraries that are installed. You can delete some files in temporary folders or see where are the secrets. This is very useful when you're deploying your app by yourself, not using the Streamlit cloud. And this has been very helpful to reduce the time I spend debugging my apps. Now, for the flow of this app, as I mentioned, by default, everything is unselected. You cannot do it. You can upload files just by dragging as usual. And there are a couple of examples that are already on the repo, so you can load the data. You can review the inputs that you're using. For instance, here we're going to see the explosion happening. You can show this and select the different frames, or you can just see the whole video of the explosion. And for this explosion, this is the mesh of all the explosives that are used. And here's where the user is providing information. So what we're going to do is to select the points on the mesh. So this is very interactive. And then we're going to select the points on the actual video. And when we finish the selection, we have a projection matrix that we can use to show the mesh on the actual video, and where we can know where everything is going on. We can select the zone where we want to have the analysis and everything which is required for the actual computations to happen. I'm not going to show more of the actual app because that's sort of protected by the company. But what was really interesting to me is to take something that ran on someone's computer and which was very complex when you saw the Jupyter Notebook, and it could be transformed into an app that anyone could use very easily, and with the help of all these components and stuff that the community is always building. So I think that would be my key takeaway, that it allows to split constructing the interface and evolving the interface from evolving the actual code, which is like where engineers want to spend most of their time.
Thanks, Sebastian, for literally sharing with us the most explosive app. And finally, we'll hear from Sumant on his AI app.
Hi everyone, this is Sumant. I'm a machine learning developer advocate here at Clarify. So just want to thank Chanin and the Streamlit team giving the chance to present one of the Streamlit app that I've just built, which does data labeling using GPT-4 Vision. If you're not sure, maybe if you have tried a multimodal model, like if you're not aware of what multimodal models are, these models are capable of taking both text and images inputs and can give you the response. So I'm not sure if you have tried, but if you just tried these multimodal models for object detection tasks, like maybe giving an image and asking it to give some bounding box coordinates of an object present in that image, you might have the hard time. Like they are not good at these tasks, like object detection, like these multimodal models. They're not good at these object detection tasks. So that's why I just thought maybe we can just use the general object detection model, which is good at detecting an object and just giving the bounding box, And then we can just use these GPT-4 Vision or maybe the latest multimodal models, which have some updated knowledge, right? Which have some updated knowledge on different tasks, different objects, and then we can just use those models to label that object. So that's what this app does, and that's I just built it with Streamlit. So let's quickly see how this app was built and what's the motive behind it. And you can see in the image itself, like I'm just giving an URL of an image, and then we're just getting a bounding box of the object, which is car here, and then we have the label on the top. If you can see, we have the label Ferrari 8112. So if you just divide this demo, the object detection, like the bounding box, the thing is being done by the object detection model, and then we are using the GPT-4 Vision model to label that. Like if you're just seeing the Ferrari 812 label on the top of the object, it's from GPT-4 Vision. So we might be asking, like, why can't we use just the object detection models to even label as well? We can just do that, but maybe object detection models, they're not good at the latest maybe the images or maybe different car brands kind of thing. For example, let's say if Tesla comes up with a new car brand, maybe these object detection models haven't been trained on that, and they're not sure what that car brand is, or maybe what that car model is. So maybe you can just use, for that cases, maybe you can just use the knowledge, these GPT-4 Vision models, like this updated knowledge of these multimodal models, and then we can just use these general object detection models, which are pretty good at detecting any kind of general objects like car, maybe bike, or maybe even the different objects, right? So that's been the motive, and you can even see the image that I just added here, which is a part of the demo. We will just see the demo in live as well, and how it works and how you can just use it as well. So that's what the app is. Maybe let's quickly see some of the things, how you can just use these models in general, and also how you can just try this app. So I have the resources in the third slide, so you can, if you want to check the GitHub repo, the code, everything available there, and the module for you to try it out, and the demo video as well, if you would like to just follow along to get more in-depth analysis, or maybe in-depth knowledge on how you can just use, or how you can just build this end-to-end using Streamlit and also using the models from Clarifai. So I'll just quickly jump into that. So if you're not aware of Clarifai, so Clarifai is a full stack AI platform that helps you to take your AI prototypes to production. So more about that later, but let's quickly see some of the models. So if you're not aware, Clarifai also has a community where you can get where you have like around 500 plus different models, like different models related to all tasks, like from image, audio, text, like all the LLMs and multimodal models. So everything is available in the community. So you can just go to the community and you can just access the models. So this is the general image detection model that I was just talking about, which is available in the community. So we're gonna use this model, and then for object, like for detecting the object and getting the bounding box, and then we're gonna use this GPT-4 Vision model, which is also from the available in the community, to get the label. So let's quickly get into the code and see how it works. So this is the code. As I just mentioned, we have the code in the third slide. From there, you can just quickly get here, and this is public, so you can just try it out. You can just access the code, and you can just clone it, and you can just try it out yourself. So you can see I'm just using Streamlit here, and then the Clarifai Python SDK. This is the app, the title that I just added, and you can see the main function here where we're just taking the image URL, and then the sidebar where we just required you to enter your personal access token. So if you're not aware of what personal access token is, so this is the token. This is, just think it of as an API key, which gives you access to all the resources that you're just trying to use from Clarifai. And since you're just trying to use this GPT-4 Vision, or maybe the image detection, or if you're just planning to use any other model, so this is what you just required, the personal access token. So you can just get that from the profile icon on the top right. You can just go to the security option here, and then you can just get your personal access token, or you can just create your own, and then you can just pass that So that's what I'm just defining the sidebar. And then in the main section, you can see we're just asking them to present the URL, like a URL of the image, which they just want to label. And then we are just using the detector model, like the object detector model, which we have just seen previously. Like just taking the model and then passing the image URL and getting the response. So you can see the response will be in the different regions, like just predicts the object which is in the image, and it gives all the images, all the objects present in the image. So from there, we are filtering out the objects which are only like the model is 99% confident. And then you can see once we just filtered that, we just having different classes, like for the car brands, as I just mentioned, Ferrari 8112, Volkswagen, BMW, Honda Civic. Like I've just given some examples here, some different classes. But yeah, just think of this as an initial stage, or maybe it's as an base example. You can just take this for any kind of example that you're just trying to build. It's not just limited to car, maybe the data labeling the car brands or maybe other things. You can just use it for any kind of use cases in any different industries, right? For example, let's say you just want to use this for manufacturing industry, right? Maybe you can just use the object detection model to detect some common objects present in that image, and then you can just leverage, instead of using GPT-4 vision, you can even use the Llama 3.2 vision model, which is also available in the platform, like the latest model, which is with some updated knowledge, right? It has some updated knowledge, so you can just use that model as well. So I'm just showing you as an example, like how you can just use different models to come up with, or maybe to build something useful. But it's up to you on how you're gonna use that and what use case you're gonna use, or maybe you can build with this. So yeah, you can see I'm just getting the bounding box coordinates from here, and then here I have the prompt here. Label the car in the bounding box region, like top, left, bottom, and right, and then giving the all the 4 classes that we have, like whichever we have here mentioned here, like Ferrari, Volkswagen, BMW, Honda. So this is the prompt, and we are passing the prompt along with the bounding box coordinates that we just got, and then we're gonna get the response from the GPT-4 vision model, and then we're just passing, like we are just using the CV2 library, which is a Python library that helps you to work with image or maybe the video data. I'm just drawing a rectangle, like the bounding box, with the coordinates that we just got from the model, and also I'm just putting the text, like the label, on top of the image that you're just seeing in the label, right? So I'm just getting the concept, I'm just passing that on the top of the image. So that's what I'm just using. You can see it's pretty simple, just leveraging Streamlit to build this. Maybe you can just deploy this in Streamlit Cloud itself, or maybe we have within Clarify, we have the module section where you can just build, like if you just think of modules, they're just built on top of Streamlit. So whatever you're just building, like the Streamlit apps, you can just bring them up and then deploy it on the Clarify cloud. So you can even find that as well, like you can just deploy in Clarify, or if you just prefer, you can just use Streamlit deploy for your application. So yeah, as I just mentioned, the tutorial on how you can just use module, how you can just deploy that into the Clarify cloud is available in the demo video which I just added in the slide, so you can just go through that. So yeah, if you just see the demo here, I'm just passing my Clarify personal access token, and then the image URL here. Obviously, you can just, this is the test image URL that I'm just passing, but it's up to you. You can just pass any kind of URL, and maybe you can just go to the code. You can just change how you just want. Maybe you can just customize it for your use case, and then once you just pass, you can see we're just getting the bounding box around the object and along with the car label, along with the label which is from the vision model. So that's the demo, that's the app. As I just mentioned, you can just find the code, you can just extend this for any kind of use case, any kind of industry. I guess I'm just hoping that this object detection, or maybe this the multimodal models will become good at the bounding box, maybe detecting the objects and drawing the bounding boxes, maybe in the future. But as of now, they are not good at these tasks. So you can just leverage these existing models along with the models, multimodal models, to come up with this use case. So yeah, I hope this is helpful. Just feel free to reach me if you have any questions or if you have any doubts in building this, or maybe in general about Clarify or in general about Streamlit. So yeah, that's it for the demo, and thanks for the opportunity from Streamlit team for showcasing this, for presenting this simple app. So I hope this is helpful, and thank you.
Sumant, we truly appreciate your demo talk, which helps us to see what's possible with AI. And with that, let's proceed to how to get involved with the community. So here you can see that there are 3 possible routes or ways that you could get involved with the community. So first, you could hang out in the Streamlit forum, where you could also help fellow Streamliters or be helped by other fellow Streamliters in getting unstuck when building Streamlit apps. We also occasionally organize in-person meetups, so do check out this link in order to find out where our latest events is happening. If you're interested in becoming one of these Streamlit creators, you could go to this link in order to find out how you could join. So all of these amazing Streamlit creators has built some pretty cool and amazing apps using Streamlit. And now to the swag drops. So firstly, thank you for joining today. And please share your feedback in this survey in the provided link here. 3 random winners will receive a swag, and subject to terms and conditions. So these are the prizes that we're giving out, and all winners will also receive a sticker or sets of stickers. And with that, thank you for joining the Q3 Streamlit Quarterly Showcase. And so until next time, happy streamliting.